Hello, good morning, and welcome to Science E-Learning Academy. Science E-Learning Academy is an online school that is available in all social media handles. We are teams of educators from various areas of expertise, and we bring to you tutorial videos on sciences. We post our contents on YouTube, and to get updated when we post our videos, you have to subscribe to the channel and click the notification bell. Subscription is free. Let's get started. Good day and welcome to Science E-Learning Academy. In today's tutorial video, we shall be looking at a problem on equilibrium of forces, and we shall be taking the problem from JAMB 1995, question number 4. Before we solve this problem, we would like to know what equilibrium is. A body is said to be in equilibrium when the net force is zero, either the vertical force or the horizontal force. Either the vertical force, let's say this is the force vertical when we talk of y-axis, either the vertical force is zero or the sum of the horizontal forces is zero. So when this condition is met, we say that this body or a body is said to be in equilibrium. And this is a condition for the action of forces, action of non-parallel coplanar forces, action of non-parallel coplanar forces. So to solve this problem, we need to make sure that if you look at this now, you see that the weight is acting downwards. And you have two ropes that is attached to, let's say this is a ceiling. If this is a ceiling, this is a ceiling. So if this is a ceiling and you have two ropes attached, then tension exists on the rope. Let's say the first tension is T and the second, so you have the same tension on the rope, and this rope is inclined at angle 30 degrees to the weight. The rope is inclined at angle 30 degrees to the weight. The equation is find the value of T. For us to solve this problem, since this force is acting vertically, so we are going to make use of this condition, that the vector sum of the forces acting vertically should be zero. So meaning that the upward vertical force should equal the downward vertical force. So to solve this, we need to resolve this force vertically. We need to resolve these forces vertically. So this is angle 90 degrees. If we take away 30 from 90, this becomes 60. The same thing applies here. Take away 30 from 90, this becomes 60. So let us find this vertical force. I will call it Fy and call this Fy2 since it is vertical force. And of course, you notice that since the tension is the same, since the angle that is inclined, that this rope is inclined at, look at it, 30 degrees, since it's the same, it means that the vertical component of the force here should equal the vertical components of the force here. So meaning that's the reason why the tension is the same. That's why we have T here. If here is 30 degrees and here is 60, so we might now denote this T1 and denote this T2. So meaning that both will have different tension on the rope. So this ceiling now is having two ropes, and in each of the rope there exists a tension that is the same for both ropes. So if we now want to find this side of the angle, so this tension, this is T, the tension here is T. So for us to now find the vertical component of this force, we now say cos is adjacent over hypotenuse. Cos is adjacent from SOHCAHTOA. SOHCAHTOA. Cos is adjacent over hypotenuse. So we say cos is adjacent over hypotenuse. So we now say cos 60 degrees is, where is the adjacent? The adjacent is Fy, and the hypotenuse is the tension. So that you have that Fy, which is the vertical component of the force, is T cos 60 degrees. T cos 60 degrees. And since Fy is the same, we can now say that the sum of the vertical forces is T cos 60 degrees plus T cos 60 degrees. So that this is the sum of the vertical component, upward force. I will use UP to denote upward. So that I have that T cos 60, this is cos 60 is 0.5. Cos 60 is 0.5. So that you have 2T cos 60. This is 2T cos 60. And we have that the vertical component of the force is 2T times cos 60 is 0.5. And this is 2 times, if you use 2 to multiply 0.5, what do you have? 2 multiplying 0.5 is just 1. So the vertical component of the force returns this. So we now have that the sum of the vertical component of the force should equal the sum of the downward vertical component of the force. So that we now have that T equals 20 Newton, since the downward vertical component of the force is 20. So this is the answer to the question. This is the answer to the question. We are going to use another method to solve this problem, and we shall use the method of triangle of forces. The method of triangle of forces. And how do we go about it? Let's look at the question again. We are going to make use of the triangle of force method. We are going to make use of the triangle of force method to resolve this. Triangle of force method. Triangle of force method. And how are we going to do that? So we are going to make this to form a closed triangle. We are going to make this to form a closed triangle. Remember, what we had here was 30 degrees. What we had here was 30 degrees, and this is 30 degrees. So what we are now going to do is that, since this force is acting downwards, is the weight. This weight is acting downwards. So we have it this way. It's acting downwards, and it's 20 Newton. And we have a force. We have two tensions that are attached vertically. We have two tensions that are attached vertically. They are attached vertically. Okay. So this. So we now, since we have found before that the angle here, we have found before that the angle here is this is 60 degrees, because this is 90. So we now have that the angle that this tension, the angle it's made with the vertical is 60 degrees, while for this tension is still 60 degrees. All right. From a knowledge of triangle, we know that the sum of angles in a triangle is 60 degrees. So meaning that here will be 60 degrees, because you have that 60 plus 60 plus x all should equal 180 degrees. If you make a subject of the formula, you now have 60 degrees. So here is 60 degrees. Now we're going to use sine relation to solve this. So we now have that 20 over sine 60 should equals, we can, since the tension is the same, I can pick this one. It should equal t over sine 60 degrees. So if I cross multiply, I'll have that 20 sine 60 degrees should equal t sine 60 degrees. So this can cancel this, so that I have a tension equals 20 Newton. See, using the method of triangle of forces, where we made this to have a closed triangle in this form, we still arrive at C, which is 20 Newton. So the value of T in this figure is 20 Newton. If you have been blessed by this video, do well to share it with your learning colleagues, and don't forget to subscribe to our YouTube channel for more interesting science videos. Good morning and have a lovely day ahead.